Welcome back, class. So this is the lecture number 12 and probably the last lecture of this unit, alkyl and aryl halide. So after this, I think your syllabus will be complete, and still if you find that there is any topic or any content you want to discuss or we missed out, then let me inform. Definitely we'll go for that, because in this aryl halide there is some compound also like chloroform, ddt, freon and all. So it is not in the syllabus, but still if you are think that yes, we need to study that, we need to read out that, so I will prepare one or two video for that also. Okay, but it's depends on the demand of the students. So the last topic of the discussion is relative reactivities relative reactivities of alkyl halide alkyl halide versus allyl vinyl and aryl halide. Okay, so as we had completed two section, one is the alkyl halide and other one is the aryl halide, and we had already know that as far as the reactivity is concerned, alkyl halide reactivity is greater than aryl halide. Okay, alkyl halide is much more reactive than aryl halide, and reason I had already explained in the previous videos. Okay, so for the first, if you go for the alkyl halide alkyl halide, I just give you a simple uh, brief about that. So alkyl halide is very good against the nucleophilic substitution reaction. We know that SN1 and SN2 reaction, and for SN1, if you're talking about the SN1, the order is tertiary, then secondary, and then primary, and the last methyl halide. Okay, this is very simple reaction. And then SN2 reaction, here we know the order is just reverse, so methyl halide, and then 1 degree, then 2 degree, and then 3 degree. So this we had already explained the whole mechanism and other points in SN1 and SN2 reaction. So alkyl has no problem. Aryl halide we also discussed, aryl halide, but vinyl and allyl halide is not discussed so far. So in this particular section we'll talk about that only. So let's talk about the vinyl halide and aryl halide. Aryl halide we had already discussed, but let discuss it in brief here. So vinyl and aryl halide, well, as we know that the alkyl halide goes for SN1 and SN2 reaction, but if you talk about vinyl halide and aryl halide, both are not capable to uh, show SN1 and SN2 reaction. Okay, cannot undergo SN1 and SN2. There are several reasons for this. Okay, there are several reasons of their low reactivity, or not low reactivity, less reactivity of vinyl and aryl halide against SN1 and SN2. Okay, so in case of SN2 reaction, I'm talking about in these two only. Okay, in case of SN2, see what happened in case of SN2. uh, For vinyl, we know that vinyl is a CH2 double bond CH and X. Okay, so this carbon is what? This carbon is sp2 hybridized. This carbon is sp2 hybridized. That means it is a planar one, 2 and 3. So it is planar one. That means a take of nucleophile can be done from both sides. Got it? A take of nucleophile can be done from both sides. And as per ascent to the order must be 1 degree, 2 degree and 3 degree. So if a nucleophile is a take from this side, here I am writing uh, here, this is the nucleophilic attack. Okay, this is the side of nucleophile attack. Now what happened here, because of presence of this pi electron, because of presence of this pi electron, nucleophile is repelled. Okay, because it is a negative charge, this is a pi electron negative charge, so this will repel. Okay, so presence nucleophile is repelled by the electron cloud. This is the electron cloud I am talking. Electron cloud of carbon carbon double bond, of carbon carbon double bond. Okay, this will repel, and if this will repel, what will happen? The reaction will not proceed, because in order to get the carbocation we require to take of this nucleophile. Now let's see the second one, and that is the uh, aryl halide. So this is the aryl compound, and this aryl compound, again this carbon I'm talking. So this carbon is what? This carbon is sp2 hybridized. Okay, this carbon is sp2 hybridized, and again the attack of nucleophile will be done from this side, nucleophile attack, and the same theory apply. This pi electron cloud will repel these attack. Okay, so this is the first reason, that why vinyl halide and aryl halide do not show any SN2 type of reaction. Okay, now let's talk about the second reason. What is the second reason? See, in the second case, uh, let's take again vinyl halide first. So CH2 double bond CH and X, which contain 3 lone pair of electron, and this is resonance hybridized. Okay, this is a resonant hybrid. This pi electron will be shift, this lone pair will shift to this side, and this pi electron will move to this side. And what will happen here, the resonating structure will occur. So CH2 here, negative charge will generate because of the movement of this electron, pi electron, and then single bond CH double bond X. Now we have only 2 lone pair, and as the charge is moving, so it is a plus charge. So this is what? This is the resonatic structure of vinyl halide. This is resonating structure of vinyl halide. Okay, structure of vinyl halide. And we already know the resonating structure of aryl halide, and this I don't think it is again explained, but let it do. So here is the X, and what will happen, this will electron move to this side, and this will go to this side. So here what is a negative charge generate, this will be a double bond, and here a positive charge. Okay, and then this negative charge will go to this side, this will come to this side. So in this next stage, here a negative charge is generated, and here double bond X with a positive charge. Okay, then this will move to this side and this will go to this side, so we'll get another structure, that is the pi electron. This is a pi electron, double bond X, positive charge, and now here a negative charge will generate. And then in next stage again the first step will form. So this is the last structure, that is exactly as the first one. Okay, so here is the, so this is what, this is the resonating structure of aryl halide. Okay, resonating structure of aryl halide. So what is the difference, what is the reason? Okay, so first reason we had explained, now second reason. Now in this case there is a double bond between what, carbon and halogen. This is a double bond, this is a double bond. So this double bond, that means the carbon halogen bond is shorter. Okay, I had already explained this one, shorter. So it requires what, higher energy. So it required higher energy, and higher energy required, so easy it will not easily break. So this is the second reason. Due to the resonating structure of vinyl and aryl halide, it is not possible to cleavage of carbon halogen bond is not possible. Okay, cleavage of cleavage of carbon halogen bond, actually it is a double bond. Okay, bond is not possible. Okay, so this is the third reason. And there is one more reason which we had already explained, that this is the sp2 hybridized. So because of sp2 hybridized, the s character is stronger, and as s character is stronger, it will hold the atom very tightly. So that is the reason that it is not takes part. So the order of SN2, we know that the order of SN2 is 1 degree, 2 degree and 3 degree, that means methyl halide should be more reactive. But in this case the resultant resonating structure is creating a problem for the SN2 reaction. Okay, now we will discuss about the SN1 reaction for the same case. So this is the page number 1, and let's talk about the so this is the page number 2, and here we'll talk about the SN1. SN2 we have already discussed. So the order of SN1, we know that the order of SN1 is what, 3, 2 and 1, and it because of what, the stability of carbocation. Okay, so vinyl and aryl halide, vinyl and aryl halide both uh, cannot undergo SN1. And reason is again, the carbocation which is produced is highly unstable compared to primary carbocation or secondary or tertiary carbocation. We all know that the tertiary carbocation is more stable. Okay, the stability of tertiary carbocation is very good. But if you go for the vinyl CH2 double bond CH and X. Okay, so CH2 double bond CH and X, and formation of carbocation is occur because of what, this is a highly electronegative element, so it will abstract electron, and what will happen, this will generate carbocation by release of this halide ion. So this is what, this is vinyl cation, this is what, vinyl cation, and this vinyl cation is highly unstable, because that is the tertiary carbocation is what, because of presence of 3 cs3 group, the stability occurs in tertiary carbocation, but there is no resonating structure also, and there is no the electron releasing group, so this will make it highly unstable. Now let's check the other one, that is the aryl cation. So aryl group is this one, and this is the X. So again this what it will give, this will give a positive charge here, and so again this is called aryl cation, and this aryl cation is again aryl cation, and this is again highly unstable. Okay, and if it is highly unstable, it is not further proceed, because it cannot be resonance stabilized even, or it cannot be uh, uh, electron donating or releasing group. Okay, so this is the reason that why vinyl and aryl halides do not undergo SN1 and SN2 reaction. So alkyl will go for SN1 and SN2, but aryl and vinyl will not go for SN1 and SN2. Now let's talk about the next one, and that is the allyl. Next is allyl halide. Allyl halide. So allyl halide, see, if you to talk about the allyl halide, uh, so let's talk about the allyl halide. So this is vinyl, vinyl we know that, so allyl CH2 double bond CH single bond CH2 and X. One point you should note that in vinyl the functional group is directly attached with a carbon which has a double bond, like you can see that this carbon has a double bond, so this functional group is attached with this carbon. But in case of allyl, functional group is attached with carbon next to a double bond. Okay, here is a double bond, so this is the different in the structure of vinyl and anyl. Now we will talk about SN1 first here. Okay, what is the SN1 uh, reason here? So SN1, for SN1 what we required, we required a carbocation, just like tertiary, secondary or primary. So as the release of this X halide, okay, this will be released, so this will give you CH2 double bond CH single bond CH2 and a positive charge. Okay, X is released out, and this is resonance stabilized. Okay, this is resonance stabilized. So how this will go for that, here what will happen, this pi electron will be shift here, so CH2, that means charge separation occur here. Okay, charge separation occur, so here positive charge is this side, here and this side. So what does it mean? It means that if it is resonance stabilized, that means it can undergo SN1 reaction. Okay, it can undergo SN1 reaction. Even if you go for the other option, like if we have this is the CH2 and X. So point to be noted is what, this is benzyl, like just like allyl, this is benzyl halide. Why it is benzyl? See, this is the carbon, and this carbon is attached with a double bond. Okay, this is the functional group carbon, and next carbon is attached with a double, just like this. This is the functional group carbon, and next carbon is attached with double bond. This is a function of carbon, and next carbon is attached with a double bond. So this is a benzyl. Again, the release of X negative. Now it will give you what? This will give you a positive charge to here, CH2 plus. Okay, and then this plus charge is what? This will give you different resonance. I'm not going to draw it, I'm just writing quickly so you will able to discuss it. This is a positive charge. What does it means? That this is the shifting of electron. Here the electron will shift, okay, and so that the positive charge will generate here, and this is the, okay, let it draw. And then in the second case, what will happen? This electron will be shift to this pi electron will shift to this side. The positive charge will generate to here. So in the next stage, plus charge and double bond CH2, and next stage what will happen? This will move to this side, so plus charge will generate to here. Here is the plus charge, and this is the pi electron, and double bond CH2, and then in the final stage we'll get the product CH2 plus, and okay, so this is the resonance stabilized benzyl cation. Resonance stabilized benzyl cation. That means the allyl halide undergoes the SN1 reaction more readily. Okay, even I would say as allyl halide uh, allyl halide undergoes SN1 reaction more readily even than alkyl halide, even than alkyl halide. Some of the book written this is statement, so this is very important point, but in case of SN1 only. Okay, so this is about the allyl halide, and alkyl and vinyl we had already discussed. So now we have everything is there. So if you want to uh, write the order, actually order is writing is difficult because it has a different pattern. Okay, so we know that the overall, if you go for the overall reactivity, the overall reactivity of aryl halide aryl halide is always greater, sorry, alkyl alkyl halide is greater than aryl, no doubt about that. Okay, so alkyl halide is always reactive than aryl halide. Okay, then if you talk about the SN1 order of SN1, so we know that for SN1 tertiary is always good, so tertiary is but as we have written that SN1 reaction is better given by what? Allyl. So order in case of SN1 is what? Allyl halide, then of course tertiary, that means the alkyl halide, alkyl halide, and vinyl and aryl will not go for that, so there is no need to write that. Okay, so if you go for the overall order, just write that what would be the overall order. Okay, although it is very difficult because collectively you cannot say, but yes, for SN1 it is correct. substitution reaction is very good, given by Allyl, okay, and less by the alkyl. But overall, alkyl halide is more reactive compared to allyl halide. So this is what the comparison, as we had already uh, said, the what is the reactive reactivity of alkyl halide versus allyl vinyl and allyl halide. So alkyl halide is greater reactivity compared to aryl. Allyl halide has a greater reactivity compared to alkyl. In case of SN1, vinyl is always very less reactive. Vinyl is always very less reactive. Okay, so this is I think all about from this lecture, and of course from the unit also. And as I told you that if you think that there is need to discuss any topic or any content which I missed, or if you want to go for that discussion, please let me inform. We will definitely go for that, and we will end this syllabus or this session with one question, and that is very simple. I think there is no problem with this question, and you will be able to solve this. Vinyl chloride, vinyl chloride is an aliphatic halide, is an aliphatic halide, but but it resembles it resembles with chlorobenzene, with chlorobenzene in its property, in its property. Why? So this question, this is the question from this video, and the question, the solution is already given in this video, huh? Okay, there is no need to explore any internet or books. This is already given, you will find it very easily. So thank you so much, thank you so much guys. If you like this video, just go for the comment. If you have any question, any doubt, or any topic further need to discuss, please let me inform. Okay, thank you so much.